Hi, seventh graders. It's Mr. Unhabdi. In case you're preparing for your test tomorrow, thought I'd just walk you through this picture real quick. Most of you are probably ready, but in case you need a little extra help, here we go. So the picture you're going to draw should look a lot like this one. And when you describe it, you'll talk about the heat from the inner core, heating the mantle material, or you can use the word magma. So the magma or mantle material is heated by the core, and the molecules will start to move around a bunch more because of the heat. And as they move around, the material will expand or spread out. So you'd say here that as the mantle material is heated by the core, it spreads out and its volume increases. And this causes it to become less dense so that it rises up towards the crust. So down here, this is what this arrow means. First it's hot, which leads to expansion or more volume, which creates less density and more buoyancy. And you don't need to use the word buoyancy, but that's how it works. So it'll rise up to the crust. It's mostly trapped in here by the crust. Some can escape through the mid-ocean ridge or other cracks or openings because the crust is brittle, but most of it stays trapped. So then as new heated material comes up behind it, it's going to, or from underneath it, it's going to kind of fan out to the sides like this. And you can see that in the fish tank with the red food coloring. Likewise, on this side of the ridge, there would be a current moving this direction here. It would move up and over. And as it fans out to the side, it begins to cool. And the whole time this is happening, up here it says the lithospheric plate rides like a passenger on the mantle material underneath. So just remember the lithosphere is floating. So if it's floating, because it's less dense than this material, it can float along or move with the current. And the yellow group in class, you saw that as a person on a lazy river. You just jump in the tube, and the tube drifts along with the current. So the plate's going to move this way in this picture to the right. It'll follow the current. Right. So all the while then it begins cooling. And as we talked about in class, as it cools, the molecules kind of lose some energy, slow down, come back together. The volume of the material then decreases. It contracts. That makes it more dense, and it sinks towards the core, where it reheats and kind of kicks the process off again. So that whole thing right there is called a convection current. And there's lots more to come on this in the field of science. They're studying this real closely now to see how to really explain it better. And again, this is only part of the picture. So on the test, you should label the core. This whole orange area is the mantle. You would label the mantle. You're supposed to show a current with arrows. And you should label the lithospheric plates. And you should show which way the plates are moving. And here it's shown by this tiny little arrow. I think yours would be bigger. So you'd show this whole plate moving to the right. And notice that the plate movement matches the current underneath it. So if people draw this differently, if you had drawn your current going counterclockwise here, then you should label your plate going to the left. So just make sure your current and your plate move the same direction. All right, I hope that helps. Hopefully you're all set, and we'll see you tomorrow. If you're confused on subduction, watch the subduction video as well. All right, happy studies. See you later, guys and girls. Goodbye.